So today again we are talking about trigonometric functions on the unit circle. This is lesson 19. The goal, hopefully by the end of the period, you'll be able to find values of trig functions for any angle and using the unit circle. Okay? Please again make. If you have theta, and we let theta be any angle that is in standard position, and the points P, X, Y, good old ordered pair, be a point on the terminal side of theta. We talked about this before. We talked about this the last time. When you have an angle that's in standard position, its vertex is at the origin, its initial side is fixed to the x-axis, the positive x-axis, and its terminal side is the one that moves in this particular case.
The initial is x-axis, right?
Yes. So in this case, you have a point that's located on your terminal side, and those coordinates are x, y. They can either be both negative, they can be one be positive, one be negative. It just depends on what quadrant you are in. Okay? We let R represent the non-zero distance from P to the origin. So from that point that's on your terminal side to the origin, it represents R. And R is found by taking the square root of x squared plus y squared. It cannot equal 0. Okay? If that's the case, then the trigonometric functions of theta are defined as follows. So when you have this particular situation, sine is not opposite over hypotenuse. It is y over r. So whatever your y coordinate is, and whatever r is, after you find it by doing the square root of x squared plus y squared, that right there represents the ratio for sine of theta when an angle is in standard position.
Is there a sign for this?
Cosine theta is x over r. Tangent theta is y over x. Okay? X, of course, cannot equal 0, so be undefined. Cosecant is still the reciprocal of sine, so it is r over y. Y cannot equal 0. Secant is the reciprocal of cosine, y over x, or r over x. X cannot equal 0. And lastly, cotangent, which is the reciprocal of tangent, x over y. Y cannot equal 0. Okay? These are your trig, the ratios for those trig functions, again, for an angle in standard position. Okay? So, they can give you a point. Sometimes they'll give you pictures, sometimes you won't. You have to use your knowledge of ordered pairs to figure out exactly what quadrant you're in. And then, of course, being very careful when you figure out the exact values of your 6 trig functions. Okay? So you have a point, negative 9, 12, that's on the terminal side of an angle in standard position, and you have to find your 6 trig functions. The one thing that we don't know here, we know x is negative 9, we know y, it is 12. The one thing we don't know is r, and we can find r by basically plugging it into this formula. So, you'll have r equals the square root of x squared, which is what? 81. Plus y squared, which is 144. 81 plus 144 is 225. Now, 225, that is a perfect square that you do not need your calculator to figure out. What is the square root of 225? Say again?
No, 25.
It is 15. 625 would be.
Oh, okay. Sorry.
So now that you have your r, your x, and your y, you can find each one of the trig ratios. Sine theta is y over r, so it would be 12 over 15. Or 4 over 5. Remember, you want to reduce your fractions, just like before. When we first went over right triangle trigonometry, right into trig ratios, same thing, reduce. Cosine theta is x over r, so it's going to be negative 9 over 15, which reduces down to be negative 3 over 5. Okay? Yes, we do want cosine to be negative because wherever our point's located, our x is negative. Okay? So anything that involves that x, and it doesn't, so multiply with our denominator, it's gonna be negative. Tangent theta, let's finish this off. Y over x,
12 over negative.
which is 4 over negative 3. Now, if the denominator is negative, what does that mean to the fraction?
It's all.
It's all negative, so that's a negative 4 over 3. Let's do the reciprocals real fast. What's sine's reciprocal? Cosecant. So 15 over 12 or 5 over 4. Secant is the reciprocal of cosine, so we flip that to get negative 5 thirds, and cotangent is the reciprocal of tangent, which is
9 over 12.
3, negative 4.
so that reduces to be negative 3 over 4. Just like before, okay? This time you're dealing with a point that's on the terminal side of an angle in standard position. Questions? Be careful. Watch your signs. Over here. Let negative 2, negative 1 be a point on the terminal side of an angle theta in standard position. Find all the exact trig functions of theta. Negative 2, negative 1 is located where? Quadrant 3. So you have a terminal side with the point negative 2, negative 1. We find r by taking the square root of x squared plus y squared. What's x squared?
4.
And y squared. So what is that?
5.
Square root of 5. It is the exact value, so you're not going to plug this into your calculator to get a decimal. No, no, no. You're going to leave the radical in there. Find my 6. Do that now. Let's bring it back. So, what do we get for the sine of theta? Anybody? Negative square root of 5 over 5, because you would have gotten negative 1 over the square root of 5, but then you had to rationalize. Cosine of theta would have been?
Negative 2 square root of 5 over 5.
Good stuff. Tangent.
1/2.
It is 1/2, okay? It is y over x. Negative 1 over negative 2 reduces down to be a positive
Listen,
number.
for cosecant, can you go over that really quick, because I forgot about that, I don't remember how to do the rational on the bottom.
The rationalizing part?
Yeah, just do the math, we don't see it.
Alright, so for this one, this is what you would have had. You had to multiply by the square root of 5 to get rid of that radical in the bottom.
So it'd be negative 2 square root of 5 over 5. Okay, I thought it was,
Cosecant theta. What is it? So negative square root of 5?
Yeah.
Secant theta is what? And cotangent? 2. Okay? Do realize that in an angle, in standard position, when you're looking at the coordinate plane, okay, in the first quadrant, all sine, cosine, and tangent is going to be positive. In the second quadrant, cosine is the only positive one. In the third quadrant, tangent is the only positive one. And in the fourth quadrant, sine is the only positive one.
wait,
Okay?
what?
As in their ratios. Cosine, if you have an angle, it's in standard position that's in the third quadrant. Tangent, out of the 3, sine, cosine, tangent is going to be the only one that's positive, as we can see here. Both sine and cosine were negative, tangent
So
is
I
the only
have to
positive.
do all for the first quadrant.
Because every single one, the x values are positive, the y values are positive, so that means that tangent is also going to be positive, so that's why it's all. So all 3, sine, cosine, and tangent. Okay? So if you can remember the quadrant order, then you can remember that all students take calculus. Okay?
Wait, all.
Oh.
You guys don't always are.
Oh,
okay. Sorry.
That was so great.
Sorry.
Or is all calculus takes students?
Oh, yeah.
I just.
Oh, yeah, you guys take so.
You guys have whiteboards. You're doing this one on your whiteboards.
I'm wondering about that, because you went from first to fourth quadrant.
And
Yeah,
all right.
that's what
This one should have been signed, this one should have been cosigned. Sorry. I was like, it's also My bad. My bad. So change that. Sine is the positive one in the second quadrant. Now, when the terminal side of an angle, theta, and its standard position lies on one of the coordinate axes, that's either the x or the y axis, the angle is called a quadrantal angle. Okay? Quadrantal angle. Of course, you have four different ones. You have the one that's at 0, the one that's at 90 degrees or pi over 2 radians. You have the one that's at 180 degrees or pi radians. And then you have the one that's at 270 or 3 pi over 2 radians. Those are your different types of quadrantal angles. Don't forget, they also exist as well. And if you ever had to figure out the 6 trig functions dealing with any point that's on one of those axes, you still set it up the same way. You still have your x, you still have your y, and you can still use the formula to find r and solve it that way, okay? No big change. Same thing.
So what, can you repeat that?
So if you have a point, like the problems we just did, all the points were located in a quadrant. You can also have a point that's located on one of the axes. But it doesn't change anything, it still worked out the same way.
So it's
Just,
only the
it would either be only the x, it would be just only the x or the
y
Y
value
value
has to be
also.
0, right?
only on certain ones, and then it will be the other way around on other certain axes. It just depends on which point they give you. If they give you the point 40, what axis are you on? You're on X, so you're here. You're at this one, okay? But you still would find all 6 of your trig functions the same way. You still would. This is your X, this is your Y, you need to figure out your R and work it out that way. Just realize that some of them would end up being undefined because when Y goes into the denominator, it's going to be undefined, okay? So it still works the same way if you have a point that's on your axis. Now, a reference angle. A reference angle that's represented as theta prime. That little hash represents the word prime. Is the acute angle formed by the terminal side of an angle in standard position and the x-axis. They can be used to find trigonometric values of an angle theta as well. Okay? So reference angles are always acute angles. Okay, so they're always going to be a measure that's in between 0 and 90 degrees or 0 and pi over 2 radian. Okay? So if an angle, or if theta is an angle in standard position, its reference angle theta prime. It's the acute angle formed by the terminal side theta and the x-axis. Those pictures down there give you examples of where each of your reference angles are located based off of your angle in standard position. And how you would find them. Again, these down here will tell you how to go about figuring out your reference angle based off of the angle that's given to you that's in standard position, okay? So say they gave you 60 degrees and they asked you to find a reference angle. Well, your reference angle will equal exactly that angle because it's in the first quadrant, okay? Over here, say your angle that they give you is 35 degrees and they want you to find the reference angle. Well, to do that, all you would do is do 180 minus that to get. So your reference angle would be 45 degrees, okay? And it continues like that, so on and so forth. Let's switch over to radius. Let's see how well you do. 4 pi over 3 is theta, and they want you to find your reference angle. Well, in this case, all you do is you take theta and subtract pi from it. So what is 4 pi over 3 minus pi? Pi. Wait, what is it? Pi over 3. If you get stuck with the pi's, take them out. This is basically 4/3 minus 1. 4/3 minus 1, the same thing as saying 4/3 minus 3/3. Just 1/3. So 1 pi over 3. You can treat them without, you can treat them without the pi's. So 4 pi over 3. Just treat it as 4/3. Pi, treat it as just 1. So when you subtract them, easier to get your common denominator. So then you just end up with 1/3. Just remove the pi back.
See, I wasn't the only one confused.
It's just fractions, pi is just a real-life variable. Over here, say you had 11 pi over 6 in the fourth quadrant. What is this reference angle? Careful, you're using this. It's just positive pi over 6. Okay? All reference angles are acute. So every single one of these reference angles that we found, they were in between 0 and 90 degrees or between 0 and pi over 2. And they're positive. Yes, sir.
What happened to your fancy board?
We are about to sketch and find these different reference angles, okay? The ones I gave you before. They also work here with the negative angles. So, negative 150. We've been practicing when we did coterminal angles, you know, where these certain angles are located, okay? So this is good practice, good review. Negative 150 degrees. Where is that located? It's negative 150. A positive 150 would be located in quadrant 2, but a negative 150 is located in quadrant 3. Because remember, to get a negative angle measure, you have to go clockwise. Okay? So this will be theta. Negative 150 degrees.
Alpha theta? Wait, is it? You said
Theta.
it's the give me over. The apostrophe?
Oh no, not the negative 150 degree angle. That one's still just theta. Your reference angle is theta prime.
Okay.
Okay? And your reference angle, theta prime, would be the one that's located in between the x-axis and that particular angle. So this right here would be your reference angle. And what measure would that be?
30? Negative 30.
Just 30. It'll just be 30.
So, when finding a reference angle, can't we just take, since that's closer to 180, can we just take 180 and subtract 150? Like, is that a valid way of doing it?
Yep.
To go through the whole equation?
Well, that's the thing, the equation
That's
is
basically what it's saying.
Yep.
It's more complicated.
not complicated, it's just like a formula.
Or, I mean, yeah.
Yes. Because all reference angles are positive.
So it would be 150 minus 180 to get the reference, and that's how you get 30?
Yep.
Even if so, it's automatically, it's like a absolute value.
Over here, where is 3 pi over 4? It's located where? Second quadrant. Okay?
How did you know that?
Because it's in between I and I. So I think 3/4.
3/4 is in between 1 and a half, right? Well, a half is located up here. 1 is located here, so 3/4 will have to be in between. So your reference angle would be what? It would be what? Pi over 4. Simple enough, yes? Okay, let's look at an example. Whiteboard's out. Continuing forward, the values of one or more of trigonometric functions and the quadrant in which the terminal side of theta lies is known, then the remaining function values can be found. Okay? So, similar to what we were doing back in lesson 17, with your right triangles is that this time not only are you given a trig ratio, but you're also given another stipulation that sine theta is less than 0. Okay? Meaning that sine, the value of sine has to be less than 0, so it has to be negative. Okay? So when you're trying to figure out, okay, well tangent theta is 5 over 12. Tangent's positive. What quadrants are tangent positive? Third and third and first. Okay? But you can't draw, an angle going through two quadrants. That's why you look at the following little bit to give you a little more information. Out of the first and third quadrants, where is sine less than 0?
Third.
The third. So when you create, or when you try to figure out all the rest of your remaining trig functions, your angle is going to be in the third quadrant. Okay? Did everyone catch that?
Yes.
Okay. Now tangent. What do you know of tangent? Old school right triangles. Tangent is what over what?
Opposite or adjacent.
And bringing it into what we were talking about today, tangent is also represented how?
Y over
Y over x. Okay, so whether it is opposite over adjacent or y over x, we know that 5 is going to be what? Which value? The y coordinate, and x is going to be 12. But be careful, since you're in the third quadrant, both x and y are what? Negative. And that can really throw you off when you're trying to figure out your sine, cosines, and so on and so forth. Okay? So be very careful with that.
So we have to determine quadrant.
Not determine quadrants, but use all your information given to you to figure out what quadrant you are in. So first off, you have tangent is positive. Tangent is positive in the first and third quadrant, so that eliminates 2 of them.
It didn't stipulate the tangent. Oh, yeah.
And then, out of 1 and 3, which one of them has sine being less than 0? Third quadrant. So that's how you'll be able to figure out what quadrant it's in. Okay?
Okay.
Now, if it said sine is greater than 0, then it would have been in the first quadrant.
So tangents actually. I got it.
Sine theta. What you guys get?
Negative 5 over 13.
Negative 5 over 13. Yes, because r would have been 13. The square root of 169 is 13. Cosine of theta would have been negative 12 over 13. Remember, you are in the third quadrant, so both sine and cosine are negative. We already know what tangent is that was given to us, so let's go ahead. Cosecant.
Negative 13 over 5.
Negative 13 over 5. Secant.
Negative 13 over 12.
And cotangent.
12 over 5.
Easy enough, yes? All right. I'm going to skip over this one, but go ahead and put the square root of 3. Secant theta equals the square root of 3. Go ahead and add that in. You're going to add this to the ones you're going to do for homework. Okay? So, let t be any real number on a number line, and let p, x, y, be a point on t. The number line is wrapped into the unit circle. Then the trigonometric functions of t are as follows. This, again, is another way to represent your 6 trig functions. You have a point that is in standard position, but this time particularly it's located on the unit circle. Okay? P corresponds to angle T as seen over there. In the unit circle, points are represented as the cosine of your angle measure for your x value and sine of your angle measure for your y value. Okay? So cosine is x and sine is y. Right? This applies for your unit circle. Same similar concepts, except this time the sine of your angle is y and the cosine of your angle is x. This is used within your unit circle. Now, when you guys learned about the unit circle back in Algebra 2, we only talked about the degrees, we only talked about the radians, correct? You guys remember that? There's more to the unit circle than just radians and degrees. It's also ordered pairs, okay? So we're going to go through all the degrees, all the radians, and all of the ordered pairs, okay? And you will need to commit these to memory. Every single thing. Yes, now there are patterns, there are tricks, there are all types of different things out there in the world to help you memorize your degrees, help you memorize your radians, help you memorize your ordered pairs, okay? Because it is a pattern, okay? It really is. It truly, truly is. Yes. Sooner rather than later.
So, what's the test?
I'll say Monday. I will say Monday. And the reason why I say this is because the quicker you are to memorizing this stuff, the easier it will be to do everything from here. Okay, so if you wait till the day before the test to try to memorize the unit circle, then you are going to have an issue from here till the end. Okay?
But it's not hard.
It really isn't. It really is. It will look like a lot the first time when everything is up there, but honestly, break it down by quadrants. I tell all my students, you only need to know the first quadrant, because after that, it's the pattern. Okay? So here you go. Your first, we'll start out with the easier thing, your degrees, okay? And maybe some of you guys remember this from Algebra 2, okay? You start with 0 degrees. The next angle measure is 30. The next one after that is 45. Next one after that is 60. And this one is now 30, 45, 60, and 90. Where else have you seen those angle measures? What kind of right triangles? Special right triangles. I told you it was coming back. This is where it plays in. Okay? Let's keep going. Okay? It follows the same pattern. How far is 60 away from 90? 30. So this point is the same distance away. 1 to 90. How far is 45 degrees away from 90?
135.
Careful.
120.
How far is it from 90? 45. So you add 45 more, and it is 135. I heard somebody say it. How far is 30 away from 90? 60. So that means this point has to be the same amount.
150.
150. And this point here?
180.
180. And you keep going. It's the pattern, okay? How far is 150 from 180? 30. It follows the pattern. 30, 45, 60. 30, 45, 60. 30, 45, 60, okay? So let's keep going. What's this next point? 210. This one? 225. This one? 240.
270.
And this one is 270. So far, so good?
Yep.
Coming back to you, maybe? If not, do you see the pattern? Okay? Keep going. How far? What's this one? 300, 315, and
330.
but this is not the last angle measure in the unit circle. You go a full 360 degrees. And there are your degrees of your unit circle. Okay? We're going all the way through. Y'all stopped here in class for Algebra 2. You did a little bit extra to get that extra credit to do the radians. You guys remember that?
No.
So you got it. And now we're going all the way to the order pair. So here we go. Let's see what comes on with this next one. Huh? I'm telling you, it really is not that bad. I would say this, okay? For your radians, bring it back. For your radians, you guys know the conversion to go from degrees to radians, right? What is it?
180
Pi over 180. So if anything, if you ever forget the pattern, once you learn it, you can always default to that. The only issue becomes you end up taking a lot of time to try to convert these things again, okay? So for now, we're going to kind of use the conversion, and after a while, you start seeing the pattern, okay? Well, 0 times pi over 180.
0.
So 0 degrees is the same thing as saying 0 pi radians. Do you have to put the pi after 0? No. Okay, 0 is always going to be 0. The 0 pi. 30 degrees.
5 or 6.
That's like pi over 4.
Pi over
Oh no, that's 45. Pi over 6.
Pi over 6.
Wait, multiplying it by pi 1 over 180?
Yep, so 30 times pi over 180, 10, actually 30 can go into both of these.
Yeah.
So that's where the 6 came from. What about 45 degrees?
Pi over 4.
Pi over 4. The next one's pi over 3. Pi over 2. I want you guys to take the next minute, 2 minutes, maybe 3. I want you to keep going, give me the rest of the radians. This one is going to be 2 pi over 3. 3 pi over 4. 5 pi over 6. And this one is pi. Realize we did a lot of these already on Tuesday and Monday when you guys were converting. Okay? Some of these should look familiar, like 180 and pi, 90 and pi over 2. We actually did 270 the other day. We did 330 the other day. Did a few of these the other day. Okay? Did anybody get up to here? 7 pi over 6. 5 pi over 4. 4 pi over 3. 3 pi over 2. Okay? Until, like I said, until you guys get the pattern, and I'm telling you there is a pattern there. 300.
Oh, I see.
5 pi over 3. 7 pi over 4. And 11 pi over what? 6. Lastly, 360 degrees is 2 pi. Can anybody see a pattern?
Yeah.
6, 4, 3, 2.
They go 6, 4, 3, 2, 3, 4, 6.
Alright. But then what about your numerators? So is it a problem?
They go up by.
How about this?
Goes by ones and twos.
You go
Go up, do, like, okay, your 30s, 30, 60, 90, 120, 150, 180, 210, 240, 270, so on and so forth. Okay, the ones that are by 30s, right? Just go by 1/6. 0 over 1/6, 1 over 6, 2 over 6. What does 2 over 6 reduce down to be? 1/3. Just add a pi to it. What's 3 over 6? 1/2. 4 over 6, what's that? 5 over 6. 6 over 6 is 1.
Oh, you're
1 pi.
using the
7 over 6. 8 over 6, which reduces. 9 over 6, which reduces. 10 over 6. 11 over 6. 12 over 6. Okay, you just gotta remember to reduce, and you gotta reduce correctly. But ask me about 45s?
Yeah.
45s?
Pretty much, if looking at quadrant 1 and 2, the 45 is 1/4 of quadrant 1 and 2.
There you go. 1/4. 0 over 4. 1 over 4. 2 over 4, which is 1/2. 3 over 4. 4 over 4. 5 over 4. 6 over 4. 7 over 4. 8 over 4. There you go. Okay? Your ordered pairs. When you guys did those special right triangles, remember how you did all 6 trig functions for them? The 30s, the 45s, and the 60s? They're all right here, okay? See? Well, except for 0 and 90, clearly, but, and all the other ones. But, like I said, there's a pattern. With 0, in the unit circle, the radius of the unit circle is 1, okay? Which means from the origin to that point of 0 degrees, that length is 1. And if you think about it, it's on the x-axis. So that point, that ordered pair for 0 degrees is going to be, is it 1, 0, 0, 1? 1, 0. Because I didn't go up on my y-axis, did I? Okay. Now 30 degrees. If you recall from that last slide, cosine is the x value. So does anybody remember what the cosine of 30 degrees was, or has it easily accessible? The cosine of 30 degrees.
It's 0.866.
Ah, I need exact. I need exact. Exact.
Well, it's there is exact.
It is long decimal, but you guys did find the exact form. Back in those notes.
Oh.
Cosine of 30 degrees. Yes. Square root of 3 over 2. And the sine of 30 degrees. Gabby, you saved the classes. We'll put that up there. 1/2. That is the ordered pair for 30 degrees. Okay? So when I had you guys do this trig from the special right triangle, that's where these ordered pairs are being derived from. From those special right triangles. Okay? Since you still have it out, can you help the class out? What is the sine of 45 degrees? And the sine. Oh, my bad. Sorry.
Well, they're the same.
They are the same thing. Sine and cosine, they are. What about cosine of 60 degrees?
1/2.
And the sine of 60 degrees?
Square root of 3 over 2.
Square root of 3 over 2. Lastly, 90 wasn't one that we did, but we can use a little bit of inductive reasoning to figure out that the point is 0, 1. And there's a continuous pattern.
Yeah, because it's negative.
They're just negative. You literally just take these and flip them over. Then take those, flip them over. Take these, flip them over. You take these. So, on top of your homework, find the rest of my ordered pairs. And honestly, please don't sit there and Google it. Actually reflect it, because it will help you with the memory.